We're going to learn about two calculus theorems that are based on the derivative, and these will have various uses here and there. They're called Rolle's theorem and the mean value theorem, and they deal with having functions and saying something about when their derivative will have certain values. So Rolle's theorem says, suppose you have a function satisfying the three conditions. First is that the function needs to be continuous on an interval. And I mentioned before in the other videos that everything in calculus relies on a function being continuous, so this is the first thing that we always have to check. Second is that it needs to be differentiable. That means you can take the derivative and it exists, no problem on that same interval. The only difference in the interval is for continuity we need to be continuous on the whole interval, including a and b, the endpoints. Whereas we don't need it to be differentiable on the endpoints, we just need it to be continuous there. So you see how one is an open interval, one is a closed interval. And then the third condition that we need is that the first value of the function is the same as the second value of the function, f of a equals f of b. And this is going to say that therefore it is guaranteed that there is going to be some point in between there where the derivative is 0. So let me just give you a quick idea of this. If I, for example, look at this y value here, I see that it happens 3 times. So what I could do is I could go ahead and say this first one is my a, my second one is my b. The function is definitely continuous and differentiable in between there. And notice how there is a point where you have a horizontal tangent line. That's where the derivative is 0, also called a critical point, in between there. On the other hand, if I went ahead and called this one a and this one b, I still have continuous differentiable, same y values at the starting and end point, and again you have a point here where you have a horizontal tangent line. Now, this theorem is pretty useful in a lot of theoretical mathematics, but on the practical side of things, it's a little bit lacking because all it does is tell you that there is a place where the derivative is 0, but it doesn't tell you where exactly that point is going to be. So then you have to do more work to try to find it. Regardless, at least it does give us some sort of information about what's going on here. The mean value theorem is a slight change from Rolle's theorem. We are still going to assume that the function is continuous on the interval ab. We are still going to assume that the function is differentiable on the open interval ab here. And then the conclusion's slightly modified. Instead of saying that the derivative is going to be 0, you can't say that because you don't have the starting points and end points the same. But what you can say is that the derivative is going to be equal to this. Now, what in the world does that mean? So let me draw the picture here. And this time I'm going to pick, and let's see, let's do an A here and a B there. So we look at our y values here. Now what this is telling us is that if you were to draw the line straight between them, and I asked you what the slope of that line was, well, it would be exactly this right-hand side here, f of b minus f of a over b minus a. So that means that if you find the slope between those two endpoints, now what we can do is we can apply this theorem. It says the derivative is going to equal that number somewhere. So that means that there's going to be a tangent line somewhere, and that tangent line will be parallel to the line that joins them. So it's telling you that if you have 2 points, as long as your function is continuous and differentiable, then if you take the slope between those 2 points, you're guaranteed to have somewhere where the functions, the tangent line will have the exact same slope. And so this is particularly useful because it tells you that if you look at the average, this is right here is the average rate of change, And the slope of the tangent line is the instantaneous rate of change. And it tells you that at some point in time, the instantaneous rate of change is going to equal the average rate of change. So let me give you a real world example on this. Let's suppose that you're doing a long trip here. I don't know, maybe you're going to Vegas or something. And at the end of it, you calculate that your average speed was 60 miles an hour. Now, if your average speed is 60 miles an hour, does that mean that you're going 60 the whole time? That's very unlikely. Likely you were going faster sometimes, and then you had to slow down for traffic or whatnot. So the idea is that just because your average is 60 does not mean that you were going 60 all the time. However, the mean value theorem tells you that we are guaranteed that you were going 60 at least at some point in time. Maybe not the whole trip, but there was at least one point in time where you're going 60. Now the thing I always say is, if the police system looks at this and understands the mean value theorem, then what they could do is they could start putting machines up to keep track of where you started and where you stopped on the freeway. They could calculate your average speed based on that. So, say like the toll booths and things, they can take the average speed on that. And by calculating your average speed, if your average speed is greater than the speed limit, then even if they didn't catch you speeding, they would mathematically know that you had speeded somewhere, and they could give you a ticket for it. So it's just kind of a fun little application of this here. In our class, we aren't really going to be using either of these theorems very often, but there are some problems where they will say something like, here's a function, show that it satisfies these conditions, and then find any values that make it true for the theorem. So pretty much, you're just going to be solving either f prime of c equals 0 or f prime of c equals the slope here in order to see what the values actually happen. So that's the type of problem that you'll see. But other than that, we're not going to use this very much in this class.